Now let's come to the next level, the intermediate level worksheet of exponential growth and decay. Let's start. Question number 1. The population of a town grows according to population after time t is equal to 5000, which is the initial population, 1.08 raised to power t. Okay. First is find the population after 5 hours. That means time is given. So population after 5 hours is equal to 5000. Every t has to be replaced with 5. Now we can just simply give this input into our calculator, and that will be 7346 decimal 640. Okay, 384. Now because population cannot be in decimal or in fraction, so we have to round it off. Because this number is 5 or greater than 5, if that is, we just add 1 to this number. So 7347. Now I'll write approx. Why? Because this is not the exact population, right? This is being rounded off. So after 5 years, the population will be 7347. Let's come to part 2. In how many years? How many years? That means here t is missing. In how many years? This t is missing. The population will double. See, 5000 is the initial population, right? And if I go step by step, I have to show every single step. Then, okay, double of this is 10,000 is equal to 5,000. 1.08 raised to power t. Perfect. We have to do it like this, and then dividing by 5000 on both sides, it will be 2 is equal to 1.08 raised to power t. Somewhere I am saying decimal, somewhere I am saying point. You have to tell me which one is correct. I should say this decimal or I should say this point. Okay. Now, but if you are dealing with SAT questions like where you have to uh, choose from the MCQs, or you have, this is a subjective question where you have to give the answer only, right? You have to do it in your notebook and give the answer only. Then start from here. These two steps are not necessary because you are clear with the concepts. Start from here. This population will be twice. Okay. Now, because this is exponential equation and variable is in the form of exponent and power, so we will convert this into log. So log of 1.08 t is equal to 2. Again, okay, let me tell you. Suppose this is your question and you have to convert into log. This is exponential. Then log of e of y is equal to x, right? So my bad, log of e of 2 is equal to t. 2 is equal to t. So then it will be log of 2 over log of 1.08 is equal to t. Now, if you know how to write base and number in your calculator, you can directly solve from this step. But if you are not very confident in this input, just apply the base rule, which is log of 2 over log of 1.08 is equal to 2, right? Now, our best friend calculator is here and we will give the input, and time is going to be 9.0664, and if I round it off, 9.07 years. Now again, because it is rounded off and not the exact, so I have to mention approx. Otherwise, it will be considered like, okay, this is the proper time, but this is approximation. So don't forget to write approx. Okay. Part C. Explain what 1.08 represents. Perfect. So if we see like actual equation, amount or population after time, this can, okay, we are taking population after time is equal to initial population 1 plus r raised to the power t, right? But here At place of r, we have 1 decimal 08. So can we rewrite it as like 1 plus decimal 08? So this one is for growth, right? If you are adding sum to it, so this 1 plus is showing growth. That means it's not decay. And this decimal 08 is actually 8%, right? So if I just frame this into a sentence, it is like population is growing at the rate of 8%. Perfect. Let's come to question number 2. A bacteria culture starts with 200 bacteria. Okay, that means it is the initial number of bacteria and grows continuously. Awesome. So n of t is equal to 200. That is the initial amount. E raised to power decimal 35t. Now, you must be thinking, okay, if this is a bacteria question, like then bacteria number after time t is equal to b to the power x or time, right? But why we are doing e? See, this is the case when it is given bacteria doubles after every hour or double after every day, right? Every single day. Then we use this formula because that is kind of a discrete growth. But if it is continuously growing, right, we are just seeing it every single moment, then it shows like growth which is continuous. In that case, formula is little bit different. Again, everything is covered in the previous parts, so you must check that. Okay, so first option is A, find the number after 4 hours. That means T has to be replaced with 4. You can directly give this input or you can solve it for 1 or 2 steps. So this is 1.4, and if you multiply, that is 811 decimal 0.399934. Now because this is bacteria, so it has to be a whole number, so we are rounding it off, and because it's not the exact number, we will mention it approx. We will mention this word. It is approximate count. How long to reach 1000? Okay. How long to reach 1000? That means here number of bacteria is given, which is 1000, and 200 is initial. What is the time? First, divide by 200 on both sides. So that is 5 is equal to e raised to power decimal 5t. Now, if we go back to the previous question where time is a variable, we applied like this rule, converting exponential equation into logarithmic equation, and variable is here. But if the question is from continuous growth, we use the method applying natural log on both sides. Right? Why so? For example, if you have, okay, let's do a property log m raised to power n. This n is on m only, not the whole, not like this, right? Be careful about this. Then this is equal to n log of m. That is the property. Now I am going to apply it here. It is natural log of e raised to power decimal 5t is equal to, okay, decimal 35t natural log of e, and value of this is 1. So if this is natural log of e some power, we left with only with the power. You can try another method too, but this helps us to reduce so much of our work. This is equal to natural log of 5. Now divide by it. Okay, tell me it's decimal 35 or it's 0.35. Decimal 35 is equal to t. Am I right or wrong? You have to just comment me. Now give the input. 4.598 years is the approximate time. 4.6 again is approximate time because we are rounding it off. And it's about, no, not years. I am wrong. It's about hours. So it's because we are taking our reading hourly. Okay. No doubt it's continuous, right? But we can find growth after every particular hour too. Okay. How is continuous growth different from that of the discrete growth? Okay. That the other word is discrete. Let me tell you with the help of an amount. Suppose you have $1,000 into your bank account, and bank says you are going to get 8% interest compounded annually. That means in 1 year you are going to get interest 8%, and that is compounded annually. That means you will get it only once. So for the whole year your amount is 1000, but after 1 year that amount or interest will be added into your amount, and it is a little bit extra than 1000. Then for the again 1 year, it's that amount. Then again interest is added, and then for 1 year it's stable. This kind of growth is known as discrete growth, stepwise growth. But if it is continuous, right, that means you are getting interest every instant, every second, every fraction of second. So interest is applied every instant rather than after fixed interval. That is growth. And this is always like gives more. We will see it in next question. But I hope the difference between continuous and discrete is clear. Now let's come to our third question. A radioactive substance has a half-life of 10 years. Okay. So if this is a question of half-life, and have you have revised the lesson, our half-life formula is direct. Like material after time t is equal to initial material 1 over 2 time certain time, right, over the half life of that particular substance, whatever is that. This is the formula for half life. And here, if we just go with the like continuous growth thing, this is m0 e raised to power kt. This k is the change, like growth constant or decay constant, whatever the question is. So we can directly say k is equal to ln of 2 over half life period of that particular substance. So this again is a direct formula. Write the formula for the remaining amount mt. Okay, remaining amount mt is equal to initial amount parenthesis half time, whatever time we need to calculate, upon half life period of that substance. Question 2, find the decay constant. So if we write the direct formula, which is natural log of 2 over half life of that particular substance, so that will be 10 years. Okay, that is 10 years because that is given in our question. So then now simply you have to give this input into your question. So that is decimal 069314781. We have to round it off. Decimal 069, either this or decimal 07, right? So because we are rounding it off, so that is approximate value. Perfect. How much of 200 gram remains after 30 years? Now this is the time, right? Half-life period is 10, but we have to calculate the amount after 30 years. So this is the time, this one. So we will apply the simple formula. How much, this is how much, variable here. Initial amount 200, 1 over 2 raised to power 30, the time, over half-life period 10. Now, sometimes using calculator, right, you have the calculator so you can use it, but guessing it or calculating is a better idea. For example, in this case, I have 1 by 2 raised to power 3. So that is 8. right? Which is 25. So if you give this input or solve it orally, whatever suits you, you have to check your style. If you ask me, this method is better for me, right? We must be like using some mental math techniques. Sometimes they are easier than the calculator tricks. Okay, so after 30 years, this radioactive substance will be only 25 grams. Let's come to question number 24th. Hmm. Now, this question will tell us 1000 is invested at 5% per year. Now, if this is a question where I have to write every step, right? Okay, let's see. Find amount after 10 years. If I have to write every step, I will write it as amount after time t is equal to initial amount 1 plus rate raised to power t, right? But, okay, and substitute the value. This is 1000. 1 plus 5% raised to power time, which is equal to 1000. 1 plus decimal zero 0.05 or 0.05. Again, my question is this is equal to 1000. 1 decimal zero 0.05. Okay, we have to show every step. But if you are giving SAT, practice enough so that you can start your question from this particular step. 5% will be decimal zero 0.05. Practice, practice. Because it's growing, so it will start with 1 decimal zero 0.05. So it should be from here itself. It's saving a lot of time, it's saving a lot of energy, right? Okay. So now, first question is 10 years. After 10 years. So that means time is 10 years. Okay, come our best friend, our calculator. This is 1628.894627. Okay, I have to round it off to proper like dollars thing. So it's approximately $1,627. Now, best part is coming. Find amount after 10 years. So, I will apply the formula of continuous. That means it's not the thing that after 1 year you are going to get the interest. It's you are getting it at every instant. So in that case, the formula will be final amount is equal to initial amount e raised to power kt, right? So final amount after 10 years is equal to initial amount e to the power, it is 5%, so decimal zero 0.5 after 10 years times 10. Okay, this is times 10. Now, come on, our best friend calculator. This is 1000 times 1.6487, etc. So multiplying it with by 1000, 1648 decimal 72, or if we need to find the exact number, this is $1,649. Again, approximate. This is also approximate, right? Now see, investment amount is same. The rate of interest is again the same. But if you are getting it annually or if it is continuous, then you are getting $20 more than the, okay, $22 more than the first case. So if you invest somewhere, see if it is continuous, it is beneficial. Okay. Now we have question number 5. This is kind of DIY. Do it at your own, but if you get stuck somewhere, give me your email. I'll send you the video solution of this, right? So I hope everything is clear till now. Okay, so just revise these. We will meet in the next session with higher order thinking skill questions.